Hi, this is Mr. Weston. Today we're doing a Khan Academy tutorial video on an exercise called multiply complex numbers. So a couple things before we start. One, we need to understand how do we multiply two binomials. And when I mean binomial, I mean a two-term expression. So there's two terms in the first parentheses and two terms in the second parentheses. So I'm going to tell you how to do that in two different ways. And the second thing is we need to understand I. And I'm going to start with that. So if we're looking at I, which we see these I terms here, these two terms that just underline the two binomials that we're multiplying are complex numbers because they have a real part, which is the real number. In this case, this is a -2, an integer. And then the imaginary part. And this imaginary part, don't think of it as imaginary as made up. It's just like a different number system other than the real number system. And the reason why we have this is because I is equal to square root of -1. Normally, we can't multiply something by itself twice to get -1 because a positive times a positive equals a positive and a negative times a negative equals a positive. So how do we get something times itself twice to equal a negative? Well, that's why we have the imaginary number system. So if we have something like the square root of -16, we could break that down into the square root of -1 times the square root of 16. Well, we know the square root of 16 is 4, but then the square root of -1 we determine is I. So I times 4 or 4I, okay? So that's going to be our answer there. The second thing we need to know about imaginary numbers is if we square I, essentially that's the square root of -1 times the square root of -1. I should probably use a different color. There we go. And that's going to be equal to -1 squared, and then the square root of that, right? Well, -1 squared is +1, and square root of +1 is just 1. So that's kind of a, oops, I'm sorry, that's incorrect. Let me back that up. This is going to be equal to -1. And the reason why it's equal to -1 is anytime you square something, for example, a square root of something. Okay, so this is square root of -1 squared. So let me rewrite this again. Okay, so this is just going to be equal to -1. Anytime you square a square root, it undoes the square root. I wanted this to be equal to 5, square root of 5. And that's equal to 5, okay? And just real quick, I talked about this in other videos, but if we were to multiply square root of 5 times square root of 5, a square root times itself, you get square root of 25, and it's just the thing underneath the square root. So we get -1 when we square I, okay? So that's an important thing, and it's going to make it a little bit more complicated for us as we multiply our binomials, but I just wanted to say that up front. Okay, now moving on to the actual problem. The first thing we're going to do is, this is my preferred method. I like to just pair up the -2 with both terms in the second parentheses, and then let's make this purple. And then the 2i, the second term, with both terms in the other parentheses. So if I do that, I get -2 times 5 plus, well, actually it's going to be minus because there's a negative sign in there, so just keep in mind your negatives, minus, and then 2 times 5i, okay? And then with the purple, that's my second parenthesis, okay, it's going to be 2i times 5, so 2i times 5, and then plus 2i times 5i. And then I simplify it from there. So I'm going to use blue. I get -10 here, and then I get minus 10i. So if you multiply imaginary numbers by just a normal integer, you can just keep it as a tag, very much in the same way that if this was -2 times 5x, you'd get -10x. Very similar to that, okay? So the next one, same thing I just described, we're going to get 10i. And then for the second part, this is where it gets tricky because we have the 2 times the 5 gives us +10. But then we have I times I, and we already talked about that. We know that is equal, if we have I squared, I times I, we're going to get -1. So we have the 10 from the 2 times the 5, and then we have -1 from the I squared. Okay, and if you want me to write that in 2 steps, I can. Okay, so I squared, because we have I times I, and then that would be 10 times -1. I can combine these two right here, -10 and 10i, very much in the same way that I can do -10x plus 10x, and that's going to give me 0. So that becomes 0, and then I have -10 still out in front. So now I have -10 plus 0 plus 10 times -1. Well, that's equal to -10 plus a -10, so -20 is going to be my answer. Okay. The next method I'll talk about in the second problem. It involves this box right here, which I'm going to have to redraw, but that's okay. So negative 20 is going to be my answer here. I'm going to go ahead and type that in, negative 20. And we'll check it. All right, next question. It says multiply and simplify the following complex numbers. So basically we're doing this for every one. I'm going to show you the second method. Yeah, this works. I was a little bit surprised it was so thick, but this is perfect. Okay, so there's my box. This is the box method. My students prefer the box method. So let me know what you guys think in the comment section, maybe, that you like the box method or prefer. I call it the rainbow method, but it's just distribution. Okay, some people like to FOIL. I personally don't like FOILing. I think it's a little too messy and convoluted. All right, so I'm multiplying these two binomials, and you'll see here that I wrote this second one on the side and this first one on the top. It doesn't really matter as long as you keep those terms together that are in the parentheses, okay? And what we're doing here is we are just multiplying each box. So I'm doing the 4 times the 1 here, and that gives me 4. And then the I times the 1, and that gives me 1I. Okay, so I'm just kind of going down just like a multiplication chart. And then same thing over here. So I do the 4 times the negative 2I, and that gives me negative 8I. And then the I times the negative 2I, and that gives me negative 2. And I'll write it as I squared for now. Later I need to change it, okay? Now just like normal binomials with like x plus 2, x minus 3, you're always going to have this situation. Let me get a highlighter actually. We're going to have like terms on this diagonal here. And that's the case here as well. So I'm going to go ahead and combine terms. So I have 4, and then I have 1i and combined with a negative 8i, that gives me negative 7i. And then I have this one right here, which is really minus 2 times negative 1. So you can see that these I squareds just make it one extra kind of annoying step, if I'm being honest. And so I just have one more thing to combine, which is the 4 and the 2, which gives me 6 minus 7i. You're always going to want to write the real part first and then the imaginary part second. So 6 minus 7i. 6 minus 7. You can see the i's there. And next question. So again, I'm not sure which one you're comfortable with. I'm going to go ahead and I'm going to show you the box method again. Okay, just to do it a little quicker, and then I'll end with the other method. So 2 plus 5i on the top, 5 minus 3i on the side. I'll go green for all my calculations. So I have 10 here, 5 times 2. 2 times negative 3 is negative 6i. 5 times 5i is 25i. And then we have negative 15i squared. I know I'm going to be combining these terms on the diagonal, which gives me 19i. I have the 10 there. The 19i is positive. And then I have minus 15, and that's going to be a negative 1. So really, that's a positive 15. That takes me to 25 plus 19i, and that's my final answer. So you can see this is like a nice way to stay organized when you use this method, 25 plus 19i. And that's why my students like it. And then this is the method I prefer just because it's quicker. You don't have to draw as much, okay? So I connect these two. So I have 2 times 4 is 8, and then 2 times negative 4i is negative 8i. And I think some students don't like this method because they mix up the negatives and such. So I have negative 8i here, and then positive 8i squared. Just double checking that. Sometimes it is a little tricky keeping all the negatives straight. This gives me negative 16i when I combine those ones. I still have that 8 there. And then I have plus 8 times negative 1. I would recommend always taking 2 steps with this. If you try to do it in your head, that's where students mess up the most. 16i. And 8 minus 8 gives me 0, so that goes away, and we're left with negative 16i. And that's going to be my final answer, negative 16i. So 2 different methods there to help you out. One of them suits you. If you have any questions on any of those topics, please let me know in the comment section below. And I look forward to seeing you next time right here on Wes Explains Best.